Now, today, see if S be the area of the region enclosed by y is equal to e to the power of minus x square, y is equal to 0, x equal to 0 and x equal to 1. So here the options are given here. So first of all, to find out the area we go for integration. To find out the area we go for integration. Now the problem here is we can't do the integration of this. We can't do the integration of this. So how to solve it? First of all, let us see what will be the graph of this function. Graph of this function. Hmm, Graph of this function. This is an interesting point here. You will learn how this what is the use of derivatives, first derivative, second derivative, what is the use of it, you will learn about it. So I thought of first of all how to draw this graph. Let us take how to draw this graph. Let us see. So this is an exponential function. So this is we know that this is an exponential function. So it is usually an increasing function, but here it is a decreasing function because your f dash x will come negative. If f dash x is less than 0, then it is a decreasing function, and if f dash x is greater than 0, then it is an increasing function. Usually it is an increasing function, but here this will be decreasing function because your f dash x is less than 0. And the next important point is that this is an even function because your f minus x will be equal to fx. It will be the same. And the third most important point here, that you see that 1 by e to the power of x square, if we take limit x tends to infinity, it will tends to 0. That means when x tends to infinity, your y will be 0. That means you are not never going to get x intercept. That means you are never going to get x intercept. Again I am repeating here that you are never going to get x intercept. That means you are only approaching to 0. Means if x tends to infinity, you are only approaching to 0. That means when x tends to infinity, that means your graph will be something like this. It will be approaching to 0, but you are not. It will never have an x intercept. So never have an x intercept. So again, but it has a y intercept. Y intercept because if this is y intercept at x is equal to 0, your y is 1. At x is equal to 0, your y is 1. You will have y intercept, but you are not going to have x intercept. This is the next important point of it. So first of all, let us see its increasing and decreasing phenomena. Let us see where it increasing and decreasing phenomena. To see it increasing and decreasing phenomena, let us differentiate it. So when you differentiate it, f dash x, this will be minus 2x e to the power of minus x square, because you are going to apply chain rule. So we get a f dash x, that is equal to minus 2x e to the power of minus x square. So the critical points means where your f dash is 0. F dash is 0. Critical points, that means where your f dash is 0 is 0. So if we take 0 here, so your x will be 0. Means critical points f dash, this is the critical point where your f dash your x is 0. This is the critical point. Means your tangent becomes parallel to the x axis. Your tangent becomes parallel to the x axis. So this is the critical point. So here let us see what happens. So here if you see that at x is equal to 0, this is 0, this is minus infinity, and this is plus infinity. So if you take the value of x less than 0, what do you find? It will be less than 0, it will be positive. And if you take the value x greater than 0, if you place here, what will you get? You will get negative here. If you place the value here, this is minus 2x. If you place the value of x less than 0, you are going to get here positive value, and if you place x greater than 0, you are going to have negative value. That means you are, when you place less than 0, you are going to have negative value. What does this mean? A positive value. What does this mean? That means it is increasing here. It is increasing here, and this side the value is negative. What does it means? That it is decreasing here. Your graph is going some this like this. Now next we have to find out the point of inflection. That means where there is the point where there is neither maxima nor minima. So first of all, the important point of first derivative, that from the first derivative, by finding the first derivative you can find the critical point, the point where the graph either moves from maximum point to starts moving from maximum side to minimum side, or from minimum side to maximum side. So this is the importance of the first derivative. You can determine it. And for next, and that is when you go for second derivative, what is the importance of second derivative? The importance of second derivative, you can find the points of inflection. That is the point where the graph breaks, means that means where the point where there is neither maxima nor minima, the graph breaks. So if you go for second derivative, if you find this second derivative, what are you going to get? F double x is equal to, this will be minus 2, this will be product rule, e to the power of minus x square, then again minus this will be x e to the power of minus x square, that is sorry, this will be plus, so minus 2x, this you are going to get. So this will be minus 2 e to the power of minus x square, it is common, 1 minus 2x square, 2x square. So here this is f double dash x. So here now let us find the critical point. For if you find out the critical point, when critical points means where f double dash is 0, in critical points when f double dash is 0, so you are going to, when f double dash, your f double dash is 0, so what are you going to get here? This will be 1 minus 2x square will be is equal to 0, so x will be equal to plus minus 1 by root 2 here. Yes. So now we can draw the graph. Here you can draw the graph. So this is minus 1 by root 2, and here this is 1 by root 2. Let us take point at 0, 0. If you place here 0, that means you are going to get negative value. So here, since it is negative value, so your curve will be downward. So your curve will be downward, negative value. So curve will be downward. And let us take two other values, that is minus 1 and 1. Let us take two other values. If you place 1 here, you are going to get 1 here. So 1 here. So what will be here? 1 minus 2 minus 1 minus positive. So positive, your curve will be upward. And if you again place minus 1 here, the same, you are going to get this minus and minus positive. So your curve will be upward. This. So now we can draw the graph. So with the graph, what we are going to get, the graph is, this is the graph. This is the graph. That is minus 1 by root 2. This is, and here that is 1 by root 2, and this is 0. So we find that your graph is like this. Your graph is like this. Graph is like this because there will be a break here. This is the point of inflection. That's the point of, from the second derivative we get the point of inflection. This is the point of inflection where we get the point of inflection. So here the graph is somewhat like this. So now I have just taken an interest to show you the importance of f dash x, why f dash x is used and why f double dash x is used, To tell you the importance of this, so I have just given you an explanation to draw the how we draw the graph, how we can draw the graph of y is equal to x square. So this is the almost the graph of it. Now you know that this is little bit difficult to integrate it here. It is difficult to integrate it, so let us take another procedure, that is another, how will we know that your x square is greater than x, we know that. So minus x square will be less than minus x. So again, this e to the power of minus x square will be less than e to the power of minus x. So here you see that integration of e to the power of minus x square dx, that is from 0 to 1, that will be less than integration 0 to 1 e to the power of minus x. Let us do, this is x square greater than equal. So if it is 0, for 0, then it will be less than equal to, less than equal to, less than equal to, less than equal to, because at 0 the two values are same. So dx, so now here your x 0 to 1, x 0 to 1, so here limit is from 0 to 1, it is given to you. So this is less than this. So here we see that this this area S, this is the area S, x square, no doubt x square is greater than x, so minus x square, it will be less than minus x. So here one thing I didn't told you here, this here y is equal to e to the power of minus x square. Here you see that here for this function your domain is any real number. Your domain is any real number, that is real number, but your range here, the range is y is greater than 0 but less than equal to 1, because we know that I have already told you, here you see it tends to 0, when x tends to infinity, that means this tends to 0, means you are not going to get y intercept, but it will tend to 0. So tends to 0, so it is greater than 0, not equal to, but you are going to get, you have y intercept, because at x is equal to 0, for this function at x is equal to 0, y is 1. So you have, for this function you have your you have your this y intercept, but you do not have x intercept. This question is very important. So here why I explain this graph, because by the help of this graph you are now going to able to, it is clear now for you that the domain is R, real number, but your range is y, it is greater than 0 and less than 1, because why, because from this here you see, from this, if x tends to infinity, this tends to 0, but you are not never going to get 0. That means there is no x intercept, there is no x intercept, but you have y intercept, that is at x is equal to 0 you have 1, so your range is this. So in this range, here you see, in this range your x square is less than x, in this range 0 to 1, in this range your x square is less than x. So minus x square will be greater than your minus x. So minus x square will be greater than minus x. So now e to the power of minus x square, this will be greater than e to the power of minus x. So here the limit is given to you from 0 to 1, So the limit is given to you from 0 to 1 e to the power of minus x square dx is greater than 0 to 1 e to the power of minus x dx, minus x dx. So if we integrate this here, what you are going to get, that means let this be s, let us take this as s. So s, because it is given to you, let us take this as s. So s will be greater than your 0 to 1 e to the power of minus x dx, and integration of this s greater than e to the power of minus x by minus 1, 0 to 1. So this will be s greater than minus 1. So e to the power of minus 1 is 1 by e, and e to the power of 0 is minus 1. So e to the 0 1, so this will be s greater than 1 minus 1 by e. So your e greater than, this is your answer. So why I have, so let me tell you again one thing, that this such type of questions are important for you, and from this you have learned what is the use of f dash x as well as f double dash x. Means from the help of f double dash x we can find the point of inflection. That means where there is neither maxima nor point where there is neither maxima nor minima, that means where it is breaks, means that the graph breaks, means so we can find the point of inflection. So here we have this, I have drawn this graph for you, and I have given you by the help of this graph, means I have done this, how we draw a graph. So here you see that the most important point here, first most important point here, that this is an exponential function. So usually exponential functions, they are increasing functions, but here this is a decreasing function because f dash x is less than 0, and again it is an even function. And the most important point here, that it has no x intercept but it has y intercept, and by the help of f dash x we can find out how the graph changes. Means f dash x, we can find out, that means from negative side it will increase to up to 0 and then it will decrease, and f double dash x we get the point of inflection, and by the help of this we can draw this graph. And the next last important point, the range of this is 0 to 1, that means we have no x intercept but we have y intercept. So at this interval this is less than 0, and simple integration we get this. So this is all about this question. Here the question is, let A be a vector parallel to the line of intersection of plane P1 and P2. Means there are two planes. Suppose there are two planes, and this is the line of intersection of the two planes P1 and P2. They are the line of intersection. Means if you, it will be more clear if you draw this like this, like this. Here you say these are the two planes P1 and P2, and this is the line of intersection. Your vector A, there is some vector which is parallel to this line of intersection. Suppose this is the vector A. This vector A is parallel to this line of intersection. Let A be a vector parallel to the line of intersection through origin. Through origin means this A vector is passing through the origin, and this is passing through origin, say. Let P1 is parallel to vector this. P1 is parallel to vector this, and P2, this plane is parallel to this parallel to these two vectors. These are parallel to these two vectors. So now P1 is parallel to this vector, Here it is given that this P1 is parallel to the vectors this and this. It is parallel to vector this and this. What does this mean? This plane P1, this plane P1 is parallel. So how to proceed this? How to solve this problem? So here, um, if we do the cross product of this, that is cross product of these two vectors, if we take the cross product of these two vectors, that is 2j cap plus 3k cap and 4j cap minus 3k cap, if we take the product of these two vectors, then that vector will be perpendicular to the plane P1. That vector will be perpendicular to the plane P1. So let this be n vector. So this will be equal to I cap, j cap, k cap. So 0, 2, 3, 0, 4 j cap minus 3 k cap. अच्छा, that is 4 minus 3. So this will be I cap, this into this minus this into this, that is minus 6 minus 12. Now minus j cap, this, so this will be this 0, and last is this k cap. So here this and this, your k cap is also 0. So this comes out to be minus 18 I cap. So your n1 vector comes out to be minus 18 I cap. If we do the cross product of this, we get a vector which is perpendicular to the plane P1. Similarly, if we do the cross of these two vectors, we are going to get that vector perpendicular to the plane P2. So here n2 vector, that will be equal to cross product of this and this. So I cap, j cap, k cap, that is 0, minus 0, 1, and then k minus 1, and this is 1, 3, 3, 3 and 0. So this will be how much? Equal to I cap, this cancel out 0, 0 minus minus, that is 3, minus j cap, this and this is 0, and minus minus, that is plus 3, and then k cap, this is 0, and minus 3, this is minus 3. So this is 3 I cap minus 3 j cap minus 3 k cap. So here your n2 vector is this. So now we have got n1 vector which is perpendicular to this plane P1 and n2 vector perpendicular to the plane P2. And if we do cross again these two, that means that vector will be perpendicular to these two vectors, which will be parallel to A vector, So see the point, that means this is perpendicular and this is perpendicular. If we do the cross of this, we get a line perpendicular to both this, and that perpendicular to both this will be parallel to the your this A vector. You see here this, and perpendicular to this, that will be parallel to this vector. This will be parallel to the A vector. So now what we are going to do, we are again going to find out the cross of n1 vector into n2 vector, n1 vector cross n2 vector, that will be I cap, j cap, k cap. This is how much? Minus 1800, and this is 3 minus 3 minus 3. So this will be how much? I cap, that is this will be 0. Again minus j cap, here this and this cancels out this. So this will be 18 into 3, 54. So this will be this and this cancels out. This and this cancel out. This will be 54, and then plus k vector. So here this and this cancels out. This again, this will be 54. So here your n1 vector cross n2 vector, that will be minus 54 j cap and plus 54 k cap here. So this is your parallel to a vector, and this with this angle with this, we have to find out this vector with angle with this vector. So we have to find out the angle of this vector with this vector. So your angle will be angle cos theta, that will be equal to this dot this this dot this, that will be how much? I is 0, minus 54, and then I j j, and then k k, 54 into 2, 108. So this is minus 108, and then root over, that will be 2 square plus 1 square plus minus 2 the whole square, and again this will be minus 54 square plus 54 square. So this will be, this is modulus. So here if we solve it, how much we are going to get? Let me see. If we solve it, this will be 108, 54, 2, 6, 162, and then root over 4 plus 4, 8 plus 1, 9, and this will be 54 into 2, 54 square into 2. So 162 divided by 3 into 54 root 2. So 3 4s are 12, 3 5s are 15, 3 5s are 15, and 3 4s are 12. So 54 cancels out. So your cos theta 1 by root 2. So 1 by root 2 cos theta is equal to cos pi by 4. So your theta comes out to be pi by 4. So the angle between the two, this a vector and this the given vector is theta is equal to pi by 4. Pi by 4. Here you see, suppose that P, Q, R are three non-coplanar vectors in R cube. Let the components of a vector S along P, Q, R. R cube means real, that is x, y, z axis. It is giving about real axis, that is x, y, z axis. Along P, Q, and R be 4, 3, 5. Components of vector S along this. Components, these are the scalar components of this vector S. Therefore this S vector is equal to 4p plus 3q vector, and this is plus 5r vector. The meaning of this is this: component of vector S along this, component vector S along this respectively means that this. and if the component of S vector along this are along this are x y z, means x y z, these are the scalar component for these vectors, these are the scalar components. So your S vector, that will be x minus p plus q plus r and plus y, p vector minus q plus r vector, and then your z, that is minus p minus q plus r vector. This means these are the scalar component of this vector, and these are the scalar component of this vector. So just here, this will be what? This will be S vector, that will be uh, x y z. So here minus x plus y minus z, this is p vector, and again x x minus y minus z, that is a q vector, and again here again x y z, x plus y plus z, that is r. So now from these two equations, this and this equation, this vector, we get, what do we get? Minus x plus y minus z is equal to 4, and x minus y minus z is equal to 3, and your x plus y plus z is equal to how much? It is this is 5. So if you take these two equations, this and this, and if you add these two equations, this cancel out, minus 2z is equal to 7, so z will be equal to minus 7 by 2, and again if you take these two equations, so here if you add this cancel out, so here 2x is equal to 8, 5 plus 3, so x will be equal to 4, and if you take these two equations, here x and z cancels out, 2y will be equal to 5 plus 4, 9, so y is equal to 9 by 2. So here we get these we get the values of x, y, z. So we get the value of this x, y, z. Now putting this value in this, that is 2x plus y plus z, that is 2 into 4 plus 9 by 2, and your z is minus 7 by 2. So 8, 9 minus 7, that will be 2. That means 2 by 2, 1. So your answer comes out to be 9. So this is your answer. The main technique here is that vector S along these are the vector, are this, means along these are the vectors and these are the components, and here these are the vectors and these are the components, the same vectors. And just this is a simple question but also an interesting question. So this is all about this question. Let P, Q, R, S be the points on the plane with the position vector this. So here let me draw the graph, that is x, y, z. This is P, this is Q, and then again P, Q, R. Yes. So OP vector, OQ vector, OR vector, position vector, OS vector. So the coordinate of P is minus 2 comma minus 1, Q is 4 comma 0, R is 3 comma 3, and your S is minus 3 comma 2. So let us find out. This is M1, that is slope of PS, this will be y2 minus 2 comma minus 1, y2 minus y1 by x2 minus x1. So this will be minus 1 minus 2 minus 1 minus 2 minus 2 minus 2 minus minus plus 3. So this will be minus 3 by 1, so minus 3. Again m2, that is slope of rs, that is again 3 minus 2, that means again 3 minus minus plus 3, 1 by 6. Again m3, that is slope of rq, that is 0 minus 3 by 4 minus 3, that is equal to minus 3. Now m4, that is slope of pq, that will be 0 minus minus 1 plus 1 by 4 minus minus 1, 6, so 1 by 6. Here we find that m1 is equal to m3 and m2 is equal to m4. This means m4, that is this means that your m1, that is m1, that is ps is m1 m3. ps is parallel to rq, and m2 rs is parallel to pq. So here this shows that pq rs is a parallelogram. This is a parallelogram. This is a parallelogram. Now this is a parallelogram. So here again is a parallelogram. Now let us see, let this into this. So m1 into m2, that is minus 3 into 1 by 6 minus 1 by 2. So m1 is not perpendicular to m2, so it is not a rectangle, not a rectangle. It is not a rectangle. Since it is not a rectangle, and again let us see the distance between this distance between PS and SR. Your PS distance, PS will be how much? Root over minus x2 minus x1 the whole square, minus 2 minus minus plus 3 the whole square, plus y2 minus y1, that is minus 1 minus 2, that is minus 1 minus 2 the whole square. So this will be 1 square plus 3 square, that is 9 plus 1 root 10, and your SR distance, that will be x2 minus x1, 3 minus minus, that means 3 plus 3, 3 plus 3 6 square, and 3 minus 2 1 square, that means 1 square. So this is 36 plus 1, that is root 37. So here PS is not equal to SR. So here PS is not equal to SR. So it is not a square, not a square, not a square, and not a square. That means not a square means it is not a rhombus, not a rhombus. So this is not a rhombus because adjacent sides of the rhombus are equal, and so it is not a rhombus. Parallelogram whose adjacent sides are not equal, it is not a rhombus. And at the same time, this is not, PS is not perpendicular to RS, so it is not a rectangle. So your option 1 is Correct. So your option was parallelogram, which is neither a rhombus nor a rectangle. This option is correct.